Hello class, welcome to week 6 of Python. So this week I kind of wanted to make two videos. One video is going to be for the homework, one video is going to be kind of like a all-in-one review of everything we've gone through thus far. And I kind of felt like, based on the exams, like the exams were good and everything, but I did notice that some students did have questions about certain parts of like certain topics that we've gone through. Yes, the book does kind of go through it, but sometimes it could be confusing reading the book because if you don't have a foundational basis of knowledge when you read the book, some topics might be a little bit confusing the first time you go through it. So I kind of wanted to make this video. It might be a little bit of a long video because we're going to cover for everything from week 1 all the way to week 6, every single topic with examples and me just kind of like talking through it. I am going to use this site. It's called Code Academy. It's really good because it kind of, I guess, goes through these complicated topics and makes them as simple as possible to understand. So if you guys want to use this site as well, you're free to use it. It's called Code Academy. You just have to type in Python as for like the programming language you want to learn, and it's there. So let's go through it. So um, it starts at the very beginning. This is the welcome. For welcome, they wanted me to print out my name. I printed out my name. So comments. So we know that the first thing we're going to do is to show how to tell the computer to ignore part of a program. To do so, we use comments. Comments are used using the pound symbol. So if I wanted to create a comment, I would do like, okay, well, write a comment describing the program you want to write. I want to create a program that teaches students how to um, code better. And because it's all gray, that's a comment. Um, if I removed the pound sign, I have a series of words. Now this wouldn't be accepted. I'd have to either create it, like put quotation marks around it so that's a string, and then assign it to a a variable. Like this would be fine. But if, well, actually, I could, yeah, this is a variable and it contains a string, but if I put a pound sign in front of it, it's a comment. So, um, basically, it doesn't matter what you're doing here, even if this is a valid piece of code. The moment you put this pound sign, it becomes a comment, and the compiler no longer reads it. It's more like notes for yourself. So that's what that is. The print, we've used print a lot. So here they just want us to print hello world. I kind of already did it up here. I could just do it again. So the syntax is print, open parenthesis, and then we have to, in this case, write a string inside that says hello world. And that's really it. That's what print is. Um, so we're still really at the basic part right now. So strings can be, like we saw in the previous example of hello world, strings can be put inside double quotations or single quotations. You just have to be consistent in whichever one you choose. So in this case, I printed my name of JP, and I put it inside single quotations. If I wanted to use double quotations, I could do that too. Um, it just has to be consistent. If I put a double quotation here, I have to put another double quotation at the very end. And if I do run, it's going to print out the name. There's no difference in the way it prints it out. It's just different ways of writing the string inside your code. The output is the same. So let's move on to variables. Variables. So programming languages offer a method of storing data for reuse. Um, so we know that variables can store data and then we could use it later on. So here they want us to update the variable of meal to reflect each meal of the day before we print it. So the first variable of meal is up here. Inside meal, we stored a string called an English muffin. So when we print out, uh, well, this says print out breakfast. So when we print out meal, what's it gonna do? It's gonna print out breakfast, and then it's gonna print out English muffin. So if I do run, that's true, because it's printing out this string, and then right below it, it's printing out the variable of meal. And inside of meal, we have the string of an English muffin. Now down here, we have the same variable of meal. The only difference is we changed the value associated with meal. So instead of saying an English muffin, meal now stores the value of sandwich. So when I print out lunch and then I print out meal again, it's going to print out sandwich. And the same concept is uh, uh, follows down here. So we're changing the value of meal to pasta from sandwich. It's the same variable, but in Python, you're allowed to change the value of that variable. And if you print it out again after the fact, so like if, say I printed out, say I comment this out, right? So the meal never changed to the value of pasta. I'm going to print out dinner and I'm going to print out meal. So if we see what happens, meal still has the value of sandwich because I never changed it. If I comment this out and I run it again, English muffin is now the value of meal because English muffin was set to meal and it was never changed because we commented both of these lines of code out. The whole point is whenever you change the value of a variable and then you print it out after changing the value, the variable's value will print out differently than what it originally was. So originally it was English muffin, but because I changed it to sandwich and then I printed it out after the fact, then the Python's going to say, okay, meal is now sandwich. It's no longer English muffin. Um, that's all they're trying to show you here. It's just manipulating variables, assigning different values to those variables. That's all that's happening here. So errors, I'm not going to touch on this too much. It's just kind of like there's two different kinds of errors: syntax errors, name errors. Um, so say if I reset this workspace. Okay, so I'm going to do run. It's going to give me a syntax error. And it's telling me that the syntax error occurred on this message has mismatched quote marks. So we know that if we're using a string, the string has to be consistent in the quotation marks we use. The reason it's giving us a syntax error here is because I did a single quotation mark on the left side and then a double quotation mark on the right side. So to change it, I have to choose which one I want to keep. I'm going to do double quotation marks, so that should be fine. So if I run it, now I'm getting a name error. And the name error is because when I'm printing out this name right here, this is not a variable. If it was a variable and it stored a value, it'd be fine. But because it's just a string and it's not in quotation marks, that's why we're getting the name error. So all I have to do is put this in quotation marks and then do run, and it's fine. So that it's just like showing you the different kinds of errors that you can get in Python. That's all that's happening here. So I'm going to move on to numbers. So numbers, they're just saying that you can assign different values to variables. For an integer, you would assign a whole number, and if you have a float variable, we know that float variables, we assign decimals to them. So like 3.4 would have to be assigned to a float variable. Um, and that's all that's happening here. So if I do run, so they wanted us to create variables, create the following variables and assign integer numbers to them. So they wanted us to create release year and runtime and assign a integer number to them, any integer number. Any whole number would be accepted here. Then they wanted us to create a variable called rating out of 10 and assign a float number between 1 and 10. So this can be 1.1, 1.0, 1.1, 1.2, and so on. I did 3.4 because that's technically between 1 and 10. It's just a decimal number. If I do run, it's going to say it's fine. So that's all this is. It's just telling you that different numbers are assigned different variables based on the variable's data type. So integer, float. So we can move on. So calculations. You can also use numbers for calculations. So if I wanted to print just the calculation of a series of numbers, I can do that. So here they want us to print the result of this equation. So we're not putting anything in quotation marks because this is not a string. It's just a mathematical equation. So print 25 times 68 plus 13 divided by 28. So if I run this, it's going to give me this huge number. It's a decimal. That's fine. We're not assigning this number to a variable. If we were, we'd assign it to a float variable, but we're not. In this case, we're just printing out this mathematical equation, and it gives us this number. That's it. The user will simply see this number. It's not being assigned anywhere to be used later. It's just printing out this number. So that's all this calculation is. So changing numbers. So variables that are assigned numeric values can be treated the same as the numbers themselves. So this is just saying that if I assign a variable a number, like multiple variables numbers, so in this case quilt width and quilt length, and I assign them the number of 8, I can do mathematical equations using those variables because those variables are technically placeholders for the number 8. So just like in the previous example when I did print and then I did like 24 times 6 or something like that, in this case I can do print quilt width times quilt length, and all that's doing is print 8 times 8. So when I do that, when I run it, Python will not print out um, it's not going to print out 8 times 8, it's going to print out the result of 8 times 8, which is 64. Um, so they also want us to do print the number of squares you'll need to create the quilt. Well, here I changed the values, so I think the original values were, let's see, quilt width, quilt length. Let's make this first quilt 8 squares wide and 12. Okay. And then they want us to change it to 8. Yeah, that's all that's happening there. So exponents. So exponents, we have used this quite a bit in our homework. So Python could also perform exponentation. In written math, you might see an exponent as a superscript, so like the small number, but typing superscript numbers isn't easy on modern keyboards. Since this operation is related to multiplication, we use the double multiplication symbol. So if I wanted to do 6 to the power of something, I would do 6 and then 2 multiplication symbols, and I'd do 2. So like in this example right here, they have 2 to the power of 10, so it's 2 times 10. 8 squared, 8 times 2, 9 cubed, 9 times 3, and then 4 to the half power, or 2, is 4 times 0.5. That's all this is. If I do run, then run, yeah, it takes it. Okay, so module, we have used module quite a bit. So module is another type of division, but it gives you the remainder of the division. It doesn't give you the actual division result, it gives you the remainder. So if the remainder is 0, it's going to give you the remainder of 0. So in this case, I have a variable called my team. I assigned it the mathematical equation of 27 module 4. So how many times does 4 go into 27? So if I print out my team, it's going to give me, it's going to tell me there's a remainder of 3. So 4 went into 27, so 4, 8, 12, 16, or 4, 8, 12, yeah, 16, 20, 24. So 4, so in regular division, 27 divided by 4 would give you 6. In module division, because it only goes to 24, um, and 24, the difference between 27 and 24 is 3, that means the remainder is 3. So if I were to print out the variable of my team, it's going to print out that 3 remainder, which is why it printed out 3 up here. Down here, I did print 26 module 4, and we know 4 can only go into, well, at least 27 6 times with a remainder of 3, because if it went in 7 times, it would be 28. So 26 module 4, um, 26 minus 4 gives you a remainder of 2. So that's why we get 2 here. And if we do module 28, 28 module 4, we know that it goes in evenly, so there will not be a remainder, which is why we get 0. So if we do run, and then food for thought, this is, yeah, okay. So next, so concatenation, so if we were to combine multiple strings, we can do that by using the plus operator with the strings. So like here we have 6 different strings that all have their own value of like a string, like a series of words. If I wanted to combine them all, I can do that with the plus operator. Um, so right here I declared a whole nother variable called message. I'm equating it the value of all of these strings combined. So string 1, same up here, or the same name that I have for string 1 up here, plus string 2, plus string 3, 4, 5, 6. So message is plus all of these strings. So it's really message is the wind, which had whatever. It's this message is really all of this. So when I print message, you're going to see it's going to print out that like a whole little paragraph, and that's all it is. It's combining different strings um, with the plus operator. So here we have plus equals. So Python offers shorthand for updating variables. When you have a number saved in a variable and want to add to the current value of the variable, you can use the plus equals operator. So if I wanted, so say I had a variable, say I had the variable of total price, right? And I want to add something else to that variable. Actually, let's go here. So we have a variable of number of miles hiked, and currently the value is 12. Now, what if I wanted to add, say I hiked 2 more miles, so I hiked 14 miles. Yes, I could just do number of miles hiked equals 14, changing the value of that variable, but there's also another way of doing it. So I can do number of miles hiked plus equals 2. What this really does, or what this is really saying is um, number of miles hiked equals number of miles hiked plus 2. And so I'm doing, what it's really doing is it's saying number of miles hiked is number of miles hiked, which is 12, plus 2. So what this is going to do is it's going to give me number of miles hiked equals 14. It's just another way of doing it. It's like a shorthand. So like if you want to, I guess, add a variable plus a number to that same variable, you would do this. And there's just different examples for it. So if I could do run, yeah. So multi-line strings, this is very simple. We know if we have, oh, well, actually, yeah. So say you have a string, you have a variable called to and you're assigning it a value of a string. Now your string is going to be um, like really long, and it's gonna cover multiple lines. Instead of um, having one really long, like technically you could put this all in one line, but it'd be very long, like across your screen. Like you'd have to drag the cursor over just to see the entire string. So you can have that string in multiple lines, and the way to do it is three quotation marks, and then you could kind of like at the beginning and at the very end of your string, and then Python will recognize that that entire block of words is one string. And then when you print it out, it's going to print it out in the same um, format that you wrote it. So that's pretty useful. And this is just a review. So this is pretty much like kind of like week one. So I'm gonna move backwards. Um, go into syllabus. Go into, so now we're gonna get into control flow. So control flow is kind of like the if else if. So go all the way back to the beginning. So I went two backwards. So let's go. Okay, control flow. Go to the beginning again. So this is just an introduction of control flow. We don't really need to look at that. So Boolean expressions. So before we can get into control flow, we have to understand Booleans. So Booleans are true and false. And here they're just kind of like giving you examples. They want to make sure you understand what the difference is between something that is fact, that can be true and false, and something that's opinionated. So they give you different statements, and here I just have to reply with a string saying yes, it's like a true statement, or no, it's not a true statement. That's all this is. They're going to get into Booleans a little bit more. Okay, this is a Boolean state, or well, this is a way of defining a Boolean statement. So we use relational operators, the equals, like the double equals, and the not equals. So here, 1 equals 1. Is that true? Yes. 2 is not equal to 4. That's also true. 3 is equal to 5. That's false. The string of 7 is equal to the integer 7. That's false because even though they're both 7, one is a string and one is a number. Um, and so here they give us mathematical equations and they want us to assign the Boolean of true or false to that statement based on whether it's true. So here we have 5 times 2, that's 10, minus 1 is 9. So we have 9 on the left side, and then 8 plus 1, which is 9 on the right side. So is 9 equal to 9? Yes. So we give the Boolean value of true to the statement 1, the variable statement 1. That's all this is. Um, so Boolean variables. Before we go any further, let's talk a little bit about true and false. You may notice when you type them in the code editor, they appear in a different color than variables or strings. This is because true and false are their own special type, which is bool. So bool is its own data type. So booleans can be created in several ways. The way we did it before, so you can create a variable, assign it the value of true and false, and if we do that, that variable's data type becomes bool. You can also set a variable equal to a Boolean expression. So just like those mathematical comparisons that we saw on the previous slide, So like the 3 times 3 is 9 equal to 9? Yes. So this would equate to true if I were to type this here and then print it out. So here we created a variable called myBabyBool. We assigned it the string of true. So when we print that out and we do print type, it's going to say that's a string. Even though we wrote true, because we didn't write true like this with an uppercase T and without quotation marks, Python will recognize that as a string. Now when we write true in its actual form of uppercase T and then no quotation marks around it, Python recognizes that as Boolean. So that's all that is. We could go to the next slide. So now we're going to get into if statements. Okay, so the if statement, is used when you want to kind of compare Boolean variables or like statements. So like here we did if username and the username equals the string of Angela Cat Lady 87, does that equal the string of Dave? If so, print out get off my computer, Dave. If it doesn't, we use the else statement, but we haven't gotten to that point, well, at least in this video. Um, but like the if statement is used essentially to compare uh, different, um, I guess, variables, like a condition. So like here, if username Angela Cat Lady equals Angela Cat Lady, print I know it is you, Dave. So because we know Angela Cat, that string equals the other side of that equation of Angela Cat Lady, because they're both the same, it's going to print out this statement. That's all the if statement does. So we don't always have to just use equal for the if statement. We could use other operators. So here we have different relational operators. We have greater than or equal to, less than or equal to. So for our if statement here, we could do if age. Age is a variable. It's not a dummy variable. Age is an actual variable. Um, it can be, we don't know what the value of age is, but the if statement is asking if the variable of age is less than or equal to 13, print out sorry parental controls required. Say the value of age, which we don't know, say the value of age is 12. Is 12 less than or equal to 13? Yes. So it's going to print out that string. Now, if the value of age was 14, then 14 is not less than or equal to 13, so it's not going to print out that string, and typically it would go to the else statement, but in this case we don't have the else statement yet. But that's really all if statements are. So now we can move on to the next slide. Okay, so Boolean operators and or not. So this is just kind of like ways of telling Python, like say in our if statement, say we have the variable of credits. Credits up here, we have the value of 120 assigned to credits. We also have the value of 3.4 assigned to GPA. So those variables are already defined. Let's go to our if statement. So if credits, which in this case is 120, is greater than or equal to, and because, yeah, 120 is not greater than 120, but it's equal to 120. So technically that part of the if statement is true. Now we move on to what follows that, which is and. So and means that both statements must be true for it to run the code. So and GPA must be greater than or equal to 2.0. GPA, we know, has the value of 3.4, so it is greater than 2.4. So both sides of my statement are true. So the if statement's going to say, okay, if this side is true and this side is true, it's going to print this out. and when we run it, it does print out. And that's really all these operators are used for. We can use or, we can use not. I'm not sure if we specifically get into those. Okay, we do. Okay, so Boolean operators or, so in this case we have credits, we have GPA. Now the value of credits and GPA has changed. Credits no longer is 120, it's 118 in this case. So when we go to our if statement and we say credits, the variable of credits is greater than or equal to 120. In this case, because credits is equal to 118, this is false. This statement should not, will not, it's not true. It's false. So, but because we have the or operator says, okay, as long as one side is true, you could run the code. So just because this side is false doesn't mean this if statement is going to fail. If this side is true, the if statement will execute this print statement. So let's check. So is GPA greater than or equal to 2.0? GPA has the value of 2.0, so 2.0 is greater than or equal to 2.0. So this side is true. So the OR operator is going to say, okay, as long as one side is true, print this out. And when we run the code, it does print out, so that's good. So that's the OR operator. So the NOT operator, so this is kind of like a reversal. So if I have credits as 120, if I put not before it, this means if, um, well, it's, um, it's a little bit confusing. So it just means take whatever the value of the variable is and make it false. So even though credits is 120 up here, and credits 120 is greater than or equal to 120, typically, if I put a not in front of it, what this is going to say is make this statement false. So 120 will not be greater than or equal to 120, which is why this is going to run. Um, and let's see, GPA is not high enough. So what this is printing out is it's printing out this. So if not GPA is greater than or equal to 2.0, which is 1.8, so yeah, that's all this is. So the else statement. So the else statement was that other part. So when our if statement, it will not run. So like if credits, which is 120 up here, is greater than or equal to 120, and so and means both sides have to be true. So this side is true. So let's check the right side. So the right side GPA is greater than or equal to 2. GPA we know has the value of 1.9, so this side is not true. So that means this print statement will not run. So what happens when the if statement is not true and it doesn't run? We move on to the else statement. The else statement is always the kind of like failover option. So if this is not true, else is going to print out. So that's why the if statement isn't true here, else is going to print out by default. You do not meet the requirements to graduate. So um, there's also another statement. So like say we have multiple outcomes that can happen. It's not just yes or no. It's not if else. Say we have other outcomes that are possible. We use the else if statement called elif. So in this case we have the variable of grade and we have the value of 86. Now say we create our if statement. We want to check to see if, um, well, this if statement, this entire if statement, is used to kind of give a letter grade to the student based on his grade. So we start off the if statement saying, okay, is grade greater than or equal to 90? If so, print A. Okay, if And then below it we have elif. So elif is kind of like the next option that Python's going to try. It's not immediately going to go to the else, it's going to go to elif first. Elif is always used between if and else, if we require multiple outcomes. So in this case, we want to check every letter grade. So there's A, B, C, D, F. So to do that, we need at least like 3 elif statements, and then we could put F in the else statement. So we already have A. A belongs to the if statement. So now we're trying our first elif statement. So is grade greater than or equal to 80? Because if so, give that student a B. So in this case, 86 is greater than or equal to 80, so the student's going to get a B. But say we didn't, say grade was actually 50. The elif statement's going to say, okay, is 50 greater than or equal to 80? No. So it's going to move on to the next one. Elif, is grade greater than or equal to 70? Remember, in our imaginary situation, grade is equal to 50. So is 50 greater than or equal to 70? No. So it's not going to print out C, it's going to move on to the next one. Elif, is grade greater than or equal to 60? Is 50 greater than or equal to 60? No. So it's going to skip this print statement. It's going to now default to the else statement. For the else statement, we do not have to put a sort of argument here or like a comparison because this is just going to catch it's like the final option. So we're not allowing the code to um, like kind of compare something to see if it's true. It's just going to take it's the final option if the student is less than 60, so everything 59 and below will be assigned an F. So if we run this code, because our grade value is 86, it's going to give us B. If I changed it to 50, it's going to give me F. So that's the elif. So this is the review, so I'm just going to kind of skip that. So that is kind of the elif state or the if elif else part of our the lessons we've kind of gone through. So I'm going to skip errors because errors is just recognizing errors in Python. Let's move on to list. So list was I believe like 2 weeks before the exam, so like week 3-ish, I would say week 3-ish. So let's go all the way back to the beginning. Okay, so what is a list? In programming, it is common to want to work with collections of data. In Python, a list is one of the many built-in data structures that allow us to work with a collection of data in sequential order. So like a list, remember, a list is always surrounded by square brackets. So that's how you know, that's how you can kind of like spot out lists. If it's between, and every entry in the list has to be separated by a comma. So like, if I were to do test equals, hello, and 65, this is not a list. Because it's surrounded by parentheses, it's not a list. It must be surrounded by square brackets, like the ones up here. So that's kind of what this slide is for. So what can a list contain? A list could contain a lot of different data type values. So like you can include strings like 4, 5, and we know it's a string because it's surrounded by quotation marks. It can contain integers. It can contain floats, like float values, like so decimals. It can contain booleans, so true and false. So that's why we have true here. We have our float value of 85.5. We have our integer value of 67, and we have our string of Sam. A list can hold all of this. That's kind of like the advantage of using a list. So that's that. So an empty list. So an empty list is just kind of like you create a variable, you assign it square brackets, you don't put anything inside of it. An empty list can be used like, just have it there. We could input values into that list later on, but right now we don't know what we want to put in, but we know we want to use a list. So that's the point of using an empty list. Um, Very simple syntax. So list methods. So list methods can be used to kind of um, not create a list, but add values or remove values from a list. So like remember we had that empty list. So say I'm gonna remove this. Say this is my empty list, and I want to append. I'm gonna actually. Okay, I'm gonna comment that out for now. I have my empty list. I want to append the number 5 to that list. Because remember, this is the name of the list, and then the list method of append is going to allow us to add an element to that list. It's going to add it to the very end of the list, but because there's nothing in it, it's that end is the very beginning. So if I do run, I think I broke Python. Oh, you know what? It's probably because I removed stuff from inside of it. It didn't like it. What this would do was it would add to the list. It would be example list equals 5 is all it would do. So I'm going to move on to the next one. So append. So you can add an element tomatoes by using the append. Okay, so this is essentially what I wanted to do. So I had the empty list. I had the variable of garden. I equated it an empty list. Here I did garden.append, and I'm adding the string of tomatoes. So when I print out garden, oh, that's what I didn't do. Okay, so print out sample list. I'm gonna comment this out. Okay, so my list is 5 now. I'm like, I thought I was going crazy. Okay, so um, don't forget to print out your list to see the result. So we have the list of daisies and we have periwinkle. If we print out orders, we're going to get just those two entries. Now, when we add things with the append method, we add tulips and we add roses to the list of orders. When we print this out again, it's going to print out the new list. Um, and that's all that they're trying to show you, how you can grow a list here. So if we go to the next slide, growing the list, so we can use the plus operator. So say you have two lists. You have the list orders, which has all of these entries in here, and you have the list new orders, which have like only two entries. You want to combine the list. To combine the list, I'm going to create a whole nother variable, which is orders combined, equate it the value of orders, which is orders already up here. It's the variable of orders and the variable of new orders, and I'm using the plus operator. So this plus operator is all it's going to do is it's going to take both lists, combine the values together to create this huge list. Now it's not changing the individual lists. The individual lists remain the same. It's just combining them for this new variable that I created. So if I do run, actually I need to print this out. So print orders combined, and I'm gonna comment this out because I don't need this right now. There. So now it's the entire list 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 6, 7. So now if I also do print orders, you're going to notice that orders never changed. It's still the same. This list never changed. This is just a way of combining existing lists without changing the existing list. And I'm assigning this combined value to a brand new variable. So when I call that brand new variable, it's going to give me that combined value. But remember, the individual lists do not change. So that's that. So accessing list elements. So we are interviewing candidates for a job. We will call each candidate in order represented by Python list. First we'll call Juan, then we'll call Sophia. So say I wanted to call a specific entry in this list. I wanted to pull out that specific entry. So say I wanted to get Pam. So to do that, I need to know the element, well, the index value of each of these elements. So Michael here has an index value of 0. Why? Because it's the very first element in the list. Dwight has the index value of 1, Jim index value of 2, so it goes 0, 1, 2, 3, 4, 5, 6. So if I wanted to get the element of Pam, I'd have to know the index value. So this is 0, this is 1, this is 2, this is 3. Change that to 3. I'm going to run this. I get the string of Pam. I get the element of Pam printed out because I knew exactly which index um, to call. Remember, so when you're accessing the list by index, you have to do the name of the list, which is employees, square brackets, and then you put the number of the index that you want from the list. That's all that they're showing here. Very simple. So next, so that's a positive index. There's also negative indexes. So the negative index is a way of going from right to left. So like we know that 0, 1, 2, 3, 4, 5, that's called a positive index. It goes from left to right. It begins at the left at 0 and ends at the right at whatever it ends at. In this case it was 5. Now say I wanted to just get serial really quick, and I didn't want to count all the way through. I can use a negative index, which is the reverse. So like serial, while it's 5 on a positive index, it could also be -1 on a negative index. So -1, so serial would be -1, juice would be -2, cucumbers would be -3, milk -4, butter -5, eggs -6. And they have a table here to show you that. It's just another way of traversing a list. When you want to pull specific things out, and say this list is like 50 entries in and you don't want to count every single entry to get the specific index. If you know your entry is the very last entry element in that list, just use negative indexes and just call -1. And -1 will take the very last entry in that list. It's just um, this is kind of just like ways of taking values out of your list. We use indexes. Um, so modifying list elements. So you can also use the list index to identify a specific part of a list to replace that value. So here we have garden waitlist and we have all these entries. Now in garden waitlist, when I do garden waitlist 1, it's saying, okay, use the list garden waitlist, hover over index 1, which we know is Adam, and then assign, remember the equal sign is like to assign a new value to something, assign that part of that list this. So when I print it out, Adam no longer exists because Adam was replaced with this. And then same thing here, garden waitlist, -1. We know -1 is the last entry in that list. So we're going to replace that because we're assigning a new value of Alex. So Alex now exists as the very last entry of that list. That's all they're doing here. So shrinking, removing. I don't know if the book covered remove, but we could go over it really quick. So we can remove elements in a list using the .remove Python method. So this is another method similar to append, similar to what was the other one? Um, uh, okay, it doesn't let me go back. That's fine. But it's like similar to append, but it's remove. So say I wanted to remove a specific entry. Now I don't need to know the index of the entry. I can just know the value. In this case, the value is a string of, so like up here. So we have a list, order list, or we have a variable, and it has a value of this list. Now, if I print out that list, it's going to print out celery, orange juice, orange, flatbread. Okay. Now, when I do order list dot remove and I do flatbread, what happens is flatbread gets removed from the list. Now, I don't have to know the index number. It just removes flatbread because it takes this string and it goes through the entire list and it says, does flatbread exist in the first index? No. Second, third, fourth? Oh, it exists here. Well, I have to get rid of it. That's what it does. Um, that's all they're doing here. Two-dimensional list, I'm not going to go over because I don't believe we went over in the book. It's kind of a more complicated, uh, I guess, like subject. Um, so skip over that. Accessing two. This is kind of like once you know what a 2D list is, accessing and modifying is very similar to what we just did. So that's it for the list. So I'm going to go back, go to syllabus. Let's go. Is there another lesson? There is. We'll briefly go through this one, and then we're going to go through loops. So loops is kind of week 6 where we're at. So let's briefly breeze through this so we can get to loops. Okay, working with lists. This is just the syntax, so list, whatever method, whether it's remove, whether it's append, and then the input. Um, so adding by index insert. Okay, so insert is another way we can manipulate a list. So here we have our list. We have a variable called front display list, and then inside that variable we have a value of this list: mango, filet mignon, chocolate milk. And when we print that out, it gives us that full list. Now we're going to take that list, we're going to do the period insert method, and then the insert syntax is, okay, so um, the syntax of insert is the index you want to insert it into and the element you want to insert at that specific index. So for this, we do need to know the um, the index that we want to place it into. So remember, mango at the moment is currently sitting at index 0. So if we wanted to insert something at 0 in place of mango, we do 0 and then whatever we want to put there. So when we do print, notice that pineapple now took the spot of mango. It didn't replace mango. It took the spot and moved mango over. So that's when you're using the insert method, remember it's not replacing it. It's taking the spot and moving it over. So don't get confused with the what we learned prior. It's different. So pop, um, I don't believe we went over. I don't think we cover pop in the book, so I'm gonna skip this one. Range, we do cover range. So uh, often we want to create a list of consecutive numbers in our program. For example, suppose we want a list containing the numbers 0 through 9. To do that, we would do, okay, so we have a variable called number list. We equated the range. This is the syntax of range, so you type range and the open parenthesis and then whatever number inside of it. When we print out this range, what it's actually going to print out is this. So we have my range equals range 10. We do print my range. What it would typically print out is range 0, 10, right? So what if we don't want that? We want the actual numbers. We want 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. To do that, we have to use list. We have to use the list function. So when we print out, we could still do my range equals range 10. That's fine. But when we print it out, we have to use the list function to print open parenthesis, list, open parenthesis, my range, which is this. And what that's going to output is it's going to output every entry in that range. So 0 through 9. When we use range, if we define a specific number of like 8, and then we print it out, it's never going to give you 8. It's always going to do one less than what you give it. So like if I do 9 here, and then I do list, number list, it's going to give me 0 through 8. It's never going to give me 9. It's never going in this case, it's never going to give me 8. It's going to give me up to 7 and up to 8. So do keep that in mind when you use the range function. So the power of range, so we've, in that last slide, we used range with one number. Now we could, now this slide is basically saying you can input different, like more than one number. Because in the previous slide, every time we outputted the range, it always started at 0. Because it starts at 0 by default. But say we wanted it to start at a different number. Say we wanted it to start, in this case, so we have the list of my list equals range, but now we're giving it specific values. We're giving it a start and an end. So we're saying start at 2, end at 9. And now we print and then we use the list function. Remember, we need the list function. And then we do the name of the list. So, or the name of the variable. So it's going to output starting at 2, 3, 4, 5, 6, 7, 8. And it stops at 8 because remember, if we tell it to, if we say from 2 to 9, it's always going to be one less. So it's going to stop at 8. There's also a third input that you could use that allows you to skip numbers. So for example, we have range 2, 9, and 2. Will give us a list where each number is 2 greater than the previous number. So what this is going to do is it's going to start at 2, it's going to end at, it says 9 here, but it's really going to end at 8. And for every output, it's going to skip 2. So in the previous one, it printed out every single number, 2, 3, 4, 5, 6, 7, 8. But because we put a 2 here, it's going to skip each number by 2. So it's going to start at 2, go to 4, go to 6, and then 8, and it's going to stop there. So, let's see. We could also use it by increments of 10, so that we can kind of like skip numbers quicker. So we have, once again, the value of my range 3 equals range. We're starting at 1. So we're starting at 1 because remember, the first number right here is the beginning. The second number is the end, and the optional, well, this is optional and this is optional. But if we're going to do all three, start, beginning, and this is how many we're going to skip by. Like, think of it as increments. So when we print this out, it's going to go 1, 11, 21, 31, 41, 51, 61, 71, 81, 91, and it stops at 91, because remember, the last possible option is 99. Even though it says 100 right here, when we use range, the last possible option is 1 less than. So because the last possible option is 99, it cannot give us 101. So it stops at 91. So that's all that they're doing there. So length, we did cover length. So when we apply len, open parenthesis, close parenthesis, to a list, we get the number of elements in that list. So yes, we have a list of my list right here, and we have multiple entries, 1, 2, 3, 4, 5. What if we don't want those specific numbers to print out? So if we did print just my list, it's going to print out 1, 2, 3, 4, 5. But I don't want that. I want the number of entries in that list. So there's 5 entries. So give me the length of that list. How many entries are in that list? That's what length is giving you. So when you do len, my list, it's going to say, okay, there's 5 entries in that list. It's not going to give you the specific entries themselves. It's just going to say, I counted 5 entries in that list. If there was 10 entries, it'd give me 10. So that's all that's doing. So slicing, we did do a lot of slicing. It was even included on the test. So for this, we have a list of letters. So letters equals all of these different strings, A, B, C through G. So when you use the slicing operator, the you do have to include the colon here. So I created a whole new variable here called sliced list. I'm equating it the name of the original list, which was letters, that contains all of this, and then I do a square bracket, and then inside the square bracket, I'm telling it specific indexes that I want it to slice. So I am telling it start your slice at 1, index 1, and we know that the index starts at 0, so it's 0, 1. So what the slice operator is really going to do is it's going to cut A out, and then I'm telling it to stop at index 6. So 0, 1, 2, 3, 4, 5, 6. Okay? So when I do the slice, when I print it out, it's going to start at B and it's going to end at F because it's not going to include the last element. It's even though this is the sixth element, it's gonna exclude it and it's gonna only count these elements. So notice that the element at index 6 is not included in our selection. That's just how the slice operator works. So that's slicing. So this is slicing list 2. Okay. Uh, so this is basically just saying you don't always have to give it a beginning and end. Sometimes you can just kind of do, so in this example, fruits, we have the list of fruits, so apple, cherry, pineapple, orange, mango, and I'm slicing the list right here. So I'm doing fruits, um, square bracket. Instead of putting a beginning, I'm just doing colon n. So it's going to start at the very beginning. So by doing this, it's saying by default start at the very beginning, which is 0, and then end at n. Well, n is kind of like here they're just showing you the syntax, but here we're actually doing the actual slicing. So print fruits colon 3. So from 0 to 3. So 0, 1, 2, 3. So remember, we're not counting the third one. It's always pineapple. And it does count apple, so apple, cherry, pineapple, which is why it prints out apple, cherry, pineapple. And then the same can be done with negative indexes. So if I did the same thing, so print fruits, but -2 colon, and then this is um, the very end. Think of this as -1. So -2 and -1. So -1, -2, which is why we get mango and orange, or orange and mango. And that's all it is. So we'll move on to the next one, counting in list. So there is a way to count like the specific um, values in a list, see how many times they appear in a list. So here we have a list filled with like a variety of like repeating values. So we have I here, I shows up like what, 4 times? Okay, so if I want to count how many times I shows up in that list, I would use the count method. So we have a variable of num I, and it has the value of letters being the name of this list, period, and then I'm using the count method, and then I'm saying, okay, within the count method, tell me how many times I shows up in that list. And so when I print out num I is going to do this calculation right here, and it's going to count how many times I shows up in the list of letters, and it says 4. That's all it is. Very simple. So sorting is another way of, um, let's see, sort. Okay, so sorting is another way of, like, kind of, if you have a list that someone kind of assembled, not kind of in alphabetical or numerical order, it's just kind of all over the place, and you want to sort it so that it looks nice. So when you import it somewhere, it's like in the correct order, alphabetically or numerically. You would use the sort function, the sort method. So here we have a list that's kind of all over the place. It starts with X, Xander, Buffy, Angela, Willow, Giles. Say we want it to be in alphabetical order. We would use the sort method. So we do names. So this names being like the name of the list, period, sort, and then we would do print names. So we don't have to enter an argument here. We could just kind of just do period sort. And that's going to output, and it's going to actually do it by alphabetical order. Now, say you wanted it to be in reverse alphabetical order. Um, at that point, you would have to enter in an argument inside the sort parentheses. So same syntax, names, the name of the list, period, sort, and then inside sort we do reverse equals true. It's a Boolean statement. So we're saying reverse, being reverse, is true. So when we print it out, it's going to print out the reverse of the sort of the names list, meaning it's going to do the reverse of a typical alphabetical order. So Angel will be at the end, Buffy will be at the second to last, and Xander will be at the beginning. So it's the reverse of this list. So sorting list 2. So let's see, what are they doing here? It's the same thing. It's just more practice. Okay. And that's it for list. Okay. So that was list. Was that the... I believe that was the second lesson we just went through. I'm just going to double check. Yeah. Okay. So that was the second lesson of list that we just went through. So that was the week right before... That was like 2 weeks right before the exam. So loops, we did cover half of it before the exam. So that was like week 4-ish. Because the exam was on week 5. But loops, this whole loop section will cover week 4 and week 6. So let's get to the very beginning of loops. So okay. Why loops? So before we get to writing our loops, let's explore what programming would be like if we couldn't use loops. So if we didn't use loops and we just wanted to do something we wanted to repeat the same thing a lot of times, we would typically just write a series of print statements of the same print statement just like a lot of times. But to do that, it's like really time consuming. So to simplify that, we use loops. So here we have the for loop. We have a lot of syntax here. So here they're just giving you um, the way for loops should be. So the example here is run the code, indentation error. Well, let's reset it. Okay, run the code. We're going to get an indentation error. Why? Because the syntax of the for loop is for. You always begin it with for, and then you follow it with a dummy variable. So in this case, I want to manipulate this list, sports games. So my dummy variable is going to be game, or actually no, board games. Sorry, board games. So my dummy variable is going to be games, and then it's going to be in. In is just like a common word that is always mostly used for loops, and then we state the list that we're going to traverse. So for game and board games. Think of game as a placeholder for each of these entries on the list. So for Settlers and Catan, and board games for, just think of it like that. The reason it's giving us an indentation error is because the print statement, which is the action of the for loop, needs to belong to the for loop. And for it to belong in the for loop, we must indent. So when we run, now it's going to print out each individual game in this list. Um, Without indenting, Python doesn't know that this print statement belongs to this for statement. So indentation is important there. So right here, write a for loop that prints out each sport. Okay. So if I want to do the same thing that I just did for board games, but for this list of sports games, then I just outdent and I do for, and then I do, let's do sport as my dummy variable in sport games. And then remember, it indents for me, but say it didn't. I have to remember I have to indent, and then right here for the print, I have to print out my dummy variable, because remember, this dummy variable is being used to represent each and every entry in my list. So that's what I want to print out. I want to print out each and every entry in that list. So when I run it, it's going to print out, well, it kind of like does it right on top of the other list, but you get the point. And that's kind of like the very basic syntax of the for for loop. So for loops using range. So let's get down to the instructions. I'll reset this. So use the range function in a for loop to print out the provided promise variable 5 times. Okay, so let's go to the for syntax. So the for syntax is we know it's for, and then we have a variable up here, but do they tell us what temporary variable in range? Okay, so they actually tell you the syntax that they want you to follow. So for, I could do like p in range, and then the length is, how many times did they want us to do it? 5 times. Okay, I'll do 5. Because remember, when I do range 5, it's going to do 0, 1, 2, 3, 4. It's going to stop at 4. But technically, because it started at 0, that's 5 entries, which is what they want. And then I'll do colon. And they want me to print out promise. Because remember, promise has that string inside of it. So when I run it, yeah, I will finish the Python loops module. And this can be anything else you want. I just did P. I used P because of promise up here. It doesn't matter. Okay, so while loops introduction. So we can reset this. Okay, so examine the while loop from the narrative in your code editor. These are additional print statements to help visualize the iteration. Run the code, see what happens. When you are finished, comment out the example. I'm just going to delete it. I don't need it anymore. Okay, so let's write a while loop that counts down from 10 to 0 inclusive. Once our loop is finished, we will commemorate our accomplishment by printing out we have liftoff. Okay, so as we saw in the narrative, our key components will be a variable to keep track of count, and also help our loop eventually stop. A condition, they want us to create a variable called countdown and set it to the value of 10. Countdown equals 10, okay. So that's the variable that's going to keep track of count and help our loop eventually stop. A condition that our while loop will check on each iteration. So we do need to start our while loop. So while countdown is it's greater than or equal to 0. Let's do run. Okay, so I accepted that. I liked it. Now let's tackle the actual while loop. Define a while loop that will run our countdown variable. So remember, while loop is conditional statement and then action. So inside the action, so let's define a while loop that will run our countdown variable is greater than or equal to 0 on each iteration. We should print, so they want us to print out the value of countdown, which is going to be 10. We should also decrease the value of the countdown variable by 1. So to do that, I didn't spell this right. Okay. To decrease the value of countdown, we do minus equal, and then we do 1. Why do we do that? this is the same way, what this statement is actually doing is it's taking countdown, which is the value of 10, and it's saying, okay, countdown equals, what this really means is countdown equals countdown minus 1. So countdown equals 10 minus 1. So every time the while loop runs, it's going to take 10, subtract 1 from it, and then replace and then insert that new value into the beginning of the while statement. So at the beginning, while equals 10, because countdown equals 10, 10 is greater than or equal to 0. It's going to print out 10, and then it's going to subtract 1 from 10. And then it's going to say, okay, while 9 is greater than or equal to 0, print out 9. Now take 9 minus 1, it's 8. Put it back into the beginning of the while statement. 8 is greater than or equal to 0. And you can see from here, it prints it, it continues the same pattern all the way to 0. And then once it gets, it does take 0, because 0 is greater than or equal to 0. Once 0 is, you take countdown, which is 0, subtract 1 from it, you get negative 1. The while statement says, okay, while negative 1 is greater than or equal to 0, oh, that's not true anymore. While statement ends. The reason we do that is because we don't want to create an infinite loop of like an infinite while statement, because that's not good coding. At that point, your loop continues on and it never ends, and we want it to end. So now, the final requirement that they have for me, now that you have built our while loop, let's commemorate our success by printing out we have liftoff after the while loop. So we cannot put this print statement inside the while loop, because then it's just going to print every single time. We want it outside of the while loop, and to do that, to tell Python this print statement exists outside of the while loop, we have to put it at the same level that the while loop began. When we do that, Python realizes, okay, this part of the code is its own block of code. It doesn't pertain to the while loop. That's kind of how we separate blocks of code in Python. So we could do we have liftoff, and then we run, and it likes it. Okay, perfect. So move on to the next step. So while loops list. A while loop isn't only good for counting. Similar to how we saw for loops working with list, we can use while loops to iterate through a list as well. Let's return our ingredient list. Okay, so we have a list of ingredients right here. Actually, let's move all the way down to the example. I think it's probably better if we do that. So yeah, we can reset it. Okay, we're going to write a while loop to iterate over the provided list Python topics. First, we need a variable to represent the list of the length of the list. That will help us know how many times our while loop needs to iterate. Create a variable length and set it to the value of the length of the Python topics. Okay, so they want us to create a variable called length, equate it to the list, or the length of Python topics. Okay, perfect. So if I were to print that out, it's not actually going to print out these individual elements. It's going to print out how many elements are in the list. So 1, 2, 3, 4, 5. So if I were to print out length, it's going to print out 5. Yep. So I get rid of that. I don't think I need that. Okay, so next we will require a variable to compare our length variable to make sure we are able to implement a condition that eventually allows the loop to stop. Create a variable called index and initialize it to the value of 0. Perfect. Okay, I can actually put it up here. So let's build our loop. We want our loop to iterate over the list of Python topics, and on each iteration print I am learning about elements from Python topics. for this loop, we will need the following components: a condition for our while loop, a statement in the body to print out our condition, a statement in our body to increment our index forward. The result should output this. Okay, so a condition for our while loop. Let's do the while loop. So while length is greater than or equal to index, let's print out. And the reason I did that is because I know index is 5, so I already know it's greater than 0. So I want this to be true for a while, so that for a while, so that everything inside the while loop prints. Obviously, 5 is greater than 0, but eventually I want the while loop to finish, so every time I print this out, I'm going to subtract 1 from 5. That way, I only get 5 print statements. So inside the print statement, they want us to print out a string. I am learning about, and then let's do index. Yeah, let's try that. Ah. Um, Something is wrong with your while loop. Did you define a while loop that has a conditional statement index is less than length? Oh, it must be. Oh, okay. So the problem here is actually, let's see. Ah, okay. That's it. You can't just write index. You have to include the name of the list and then put index inside of here. Still doesn't like this. Okay. We'll wait for that code to run. It's kind of like, oh, you know what? It's the reason it was continuing to load is because I by accident created an infinite while loop because I didn't put the final condition at the end, which is what was it? Length minus equals 1. What? Oh, no, no, no. Index plus equals 1. What happened to my change here? Topics. What did I do wrong here? Um, I mean, they have this switched around, I guess. I mean, I don't see how this changes anything, but I still don't like it. Oh, it's the great. Oh, it's the equal to. They don't want equal to. Okay. Well, that is using list with while loops. They're very picky, just like Cengage, as far as like which side should go where. And this was a mistake of mine, but everything else was relatively good. So infinite loops, we already saw an infinite loop. The reason it was like loading for it wasn't loading was because it was an infinite loop. When you don't tell the list when to end, like if you don't do that, like the student minus equals 1, something like that. That way you're like subtracting 1 from the the comparison value, then the list will just continue on forever. Um, we saw that in the previous example when I didn't include this line right here, and I ran it. You notice it's just like circle. It's like the circle load thing. And Python's like doesn't like it because that means the while loop never ends. So do index minus equals 1. Okay. So I'll go to next. So control break. So loops in Python are very versatile. Python provides a set of control statements that we can use to get even more control out of our loops. So we have a list right here. Items on sale, and it has all these elements in the list. So if we create a for loop and we have our dummy variable and then we have our list name right here. So for item in list, items on sale, if the item, like if one of these things, one of these elements equals this string of knit dress, which we know appears right here, print found it. So that's like an if statement inside a for statement. And the reason we do that is so that we could use the break statement. So like right here, we have the list right here. This is just like a generic print statement telling the user that it's going to check the list. It doesn't actually do it. It's just words. The for the for statement here is what's actually going to do it for us. So same syntax for the dummy variable item in items on sale, like the list, print item. So what this is going to do is every time this for statement runs, it's going to print out an element from the list in sequential order from left to right. Now, this if statement is also going to run because it's going to check to see if the item, if whatever item they're on equals knit dress, break. And what break does is it tells the for loop, like the entire for loop, stop. Stop printing out the item. You're done. It's just another way of ending the for loop. And then at the very end, notice that the print statement is outdented so that it's in the same line as the for loop. This means that this print statement that says end of search will not run with the for loop. It runs after the for loop finishes. Um, and then also notice that the break is indented even further so that it belongs to the if statement and not the for statement. Even though the break ends the for statement, the break only executes if this if statement is true. And that's why it's indented. And that's what they're basically showing here. Just press, okay. So loop control, continue. While the break control statement will come in handy, there are other situations where we don't want to end the loop entirely. What if we only want to skip the current iteration of the loop? So here we have a list of numbers, and then we also have a for loop. So for I, which is the dummy variable, in the list of big number lists, so like for a specific element in this list, so like say 1, 2, -1, if and now we have an if statement inside of it. If the dummy variable, so like if say -1 is less than or equal to 0, continue. And what that means is it's going to skip that entry. So it that condition must be true for it to skip the entry. So this for statement is basically used to print out only positive integers, which is why the output is this, even though there's negative values in this list. Every time this for statement sees a negative value, it's going to skip it with the continue word, with the continue keyword. If, like say, if I, like say 2, say when the for loop is going through this list, it hits 2. If 2 is less than or equal to 0, which is false, then because it's false, the if statement doesn't run, which means continue never happens. And the for statement then prints out I, which is 2. Notice this print statement belongs to the for statement, and we know that because it's indented. It's not indented like continues indented, because if it was indented the same way as continues indented, that means that print statement belongs to the if statement, and it would be skipped. But because it's indented the same level as if, that means that if belongs to for, but print also belongs to for, because they're indented the same level. So just keep that in mind. That's all continue does. It just allows you to skip certain elements in a list that you may not want to output to the user. Um, so we can go on to the next one. So nested loops. Actually, I'll briefly go over nested loops. We're not going to go over list comprehensions. I did include it in the PowerPoint, but I don't believe we go over it in the book, so it's not too important right now. So nested loops is just another way of becoming very granular with lists. So say we had a variable, and the variable contained multiple lists. And the reason, so we have an example here. We have project teams, and it has the value of 3 different lists. And the reason I know that it's 3 different lists is because these lists begin and end with square brackets. So this first list has 3 entries or 3 elements in it. The second has 2 elements, and the third has 2 elements. So if I were to use nested loops, well, let's do a regular loop first. So the regular loop is for the dummy variable of team inside the list of project teams. And if I were to print team, which is the dummy variable, what it's going to do is it's going to print out each of the 3 lists that exist in project teams. But the way it's going to print it out is it's going to print it out in list form. So it's going to print out the first list with the brackets and the quotation marks and every element inside that list. But what if we just want the specific elements from all of those lists? We don't want the square brackets, we don't want the quotation marks, we just want the element itself. But we want the element from every single list and combined, not separated. For that, we use nested loops. So the syntax of a nested loop is kind of the same as a regular loop, a regular for loop. So we start off our loop with for, and then we use the dummy variable of team in the list of project teams. But within it, when we indent, we create another for statement. And in that for statement, we create a brand new dummy variable, and this dummy variable is going to be called student. And then student is going to represent the specific element inside each of those individual lists. And then instead of calling in project teams, we're going to say in team. That way we can get, that way student, because it's representing the specific element, it's going to traverse the team list. And that team list, if we go up and we look at this output, it's these specific lists. Instead of traversing this huge list, it's going to traverse this specific list. That way, when it prints out student, it's printing out only the specific elements that we want. So Ava, Samantha, James. It's not going to print it out in list format. It's just going to print out those specific names. So that's kind of what nested loops is for. It's like when you have multiple lists and you want the specific element itself. You have to use nested loops. So that is nested loops. Like I said, we're going to skip list comprehension. And then we'll go to list comprehension conditionals. We'll skip that too. And then we get to the review. So review, I'm not going to go through this because we just kind of went through it. And then that's pretty much it. That's week 6, up to week 6. And let's see, we'll get I did post another document on Blackboard. It is the loops overview. So let me see if I can share my screen on that. So I'll do display capture. Oh. Okay. Can you guys see? Actually, no. I'm gonna get rid of this really quick. Okay. I'm gonna do. Let me open up Blackboard because I do have it there. I think that'll be easier. So I'll open up Blackboard because I did post it there. So it's under week 6 folder. Yeah, week 6 folder. I called it additional loop resources. So now if I do, okay, perfect. So this, it's like 11 pages. It specifically lists the topics that we go over in week 6. So like the for loop, the range function, nesting loops, break, continue. And then I highlighted each main topic. So like this is the first topic, for loops, and then it kind of breaks down like the syntax of it, breaks down each component of this. It gives you examples of the for loop in use. So they give you a list, they give you the example, so like for, the ingredient, which is the dummy variable, remember? It's not an actual variable, it's just a placeholder to represent each of these entries in the list. In, and then we have the actual list name, and then remember, when we do the print statement, which is the action of the for loop, we have to call the dummy variable, because the dummy variable, remember, represents each of these entries. So that's the for loop. They do kind of go into like the temporary variable, that's what they call it. And then the for loop using range, we went over that. The while loop, with list, the break, continue, and nested loops, and that's it. So it's 11 pages. I kind of just went over them in the video myself, but this is also here if you want to read through it as well, in case like, you watch the video and then you're like, well, I still don't kind of get it. I wish I could kind of like see the kind of like a breakdown of it, like in written form. That's what this is here for. So like that resource is there for you if you need it. But I hope this whole video, I know it's long, but there was a lot to cover from week 1 to week 6, and I feel like, yeah, the book is really good for introducing the topic to you, but if you want to kind of like get a full understanding of that content, I felt like this video was necessary. So every week from here on, we're going to have one of these videos. But it's not going to be as long because it's only going to cover that week's topic. But I feel like it's important to have these videos in addition to the homework assistance, which I'll also be posting on Blackboard. But I feel like this video is a little bit more important than that because, yeah, the homework does use the topics that I'm explaining in this video, but it's important to understand the topic itself, not just like copy and pasting code. If you understand the topic, once you get to the homework, it's like, oh yeah, we went over the range function, we went over for loop syntax. I can do this, and if I know how to end a while loop, I know how to end a for loop so it never ends, so it never infinitely continues. So that's pretty much it. I hope this was helpful. Um, you guys can let me know if you guys want to send an email, say, yeah, Professor, this was helpful, or if it wasn't, then you guys can let me know too. Yeah, it's pretty long, but in future videos, it's going to be a lot shorter. And that's pretty much it. So I'll see you guys in week 7.